Hello all, welcome to the video lecture on bisection method, a course project done under the guidance of Dr. Pulikishwar sir. My name is Rav Kumar and my roll number is 620135 and my topic is bisection method algorithm using CPP, and here are the contents: introduction of the bisection method and the algorithm and the numerical example on the bisection method and the advantages of the bisection method over other search methods and the applications, real life applications of the bisection method. And next, the introduction. The bisection method is a well-known numerical method that can be used to find the roots of a function. However, it is also useful in optimization techniques where we need to find the maximum or minimum value of a function. The bisection method is a simple and easy to understand algorithm. It works by dividing the interval of interest into two subintervals and then evaluating the functions at the midpoint midpoint of the given interval. Depending on the value of the function at the midpoint, we can then discard one of the subintervals and repeat the process on the remaining subinterval. This process is repeated until a satisfactory solution or optimal solution is obtained. The bisection method is also a very robust method since it does not require the function to be differentiable or to be continuous. Here, it is also known as intermediate value theorem. F of x is a continuous on the interval a comma b, and the main condition is the sign of f of a should not be equal to the sign of f of b, and there will be existing a c value in the interval a comma b. And here is the algorithm of the bisection method. At first, we should start by selecting an initial interval a comma b that is containing the optimal solution. This means the f of a and f of b should have opposite signs and indicating that there is a root of the function within the interval. We should compute the midpoint by the formula c equals to a plus b by 2, and we should evaluate the point f of c. If we get the f of c value as 0, we can know that we obtain an optimal solution. If not, we should repeat the process until we get the optimal solution. Here is a numerical example with the given f of x equals to x cubed minus x minus 1. Consider the initial values of x are 0, 1, 2, and the f of x values are minus 1, comma 5. We should perform the iterations. Here I have performed up to 5 iterations, and in the 11th iteration we get an optimal solution. C 1 f c equals to a plus b by 2, and the 11th iteration we got the value 1.3247. And why we need a bisection method? Bisection method is very simple to understand, and it also required fewer number of computations, and it is a robust method in which the optimal solution is definitely guaranteed. The convergence rate is higher compared to other algorithms. It also has wide range of applications. It only requires a less amount of space. And application realizing the bisection search. It also used in short detection in video content for digital library, and it also used to determine the adequate population size, and it also locate and compute the periodic orbits in molecular system. And here are the references for the bisection method. The real life application of a bisection method can also be used in for determining the equilibrium point between demand and supply curves in economics. In this context, the object method is to find the quantity demand equals the quantity supplied. So I have done a source coding, and I have performed the real life application on demand and supply curves in economics. To use the bisection method in this context, we start with an initial range of possible prices, say 0, 100 in the interval, and evaluate the demand and supply functions at the midpoint of the interval. If the quantity demanded is greater than the quantity supplied, we note that equilibrium price must be lower than the midpoint and vice versa. We can then discard the subinterval that does not contain the equilibrium price and repeat the process with the remaining subinterval. We continue this process until we obtain satisfactory solution, i.e. a price at which the demanded equals the quantity supplied. For example, suppose the demand function is given by Qd equals to 100 minus 2p and the supply function is given by Qs equals to 20 plus p, where p is the price and Qd and Qs are the quantities demanded and supplied respectively. We start with an initial range of possible prices, say 0, 100, and evaluate the demand and supply functions at the midpoint of the interval. So we should have to perform the iterations C, and see, we denote a value. We took the interval, lower bound of the search interval is 0 and the upper bound of the interval is 100. So we have to find an equilibrium point between these interval, and by performing this code, by running this code, and I got an equilibrium price is 30 between the interval 0, 100. So I conclude that bisection method is a powerful tool in optimization techniques that can be used to find the minimum or maximum value for a defined interval. However, it may not converge quickly for some functions or where the initial interval is not chosen correctly. Thank you for your attention.